Good afternoon, fellow students. My name is Josh Brooks, and today Amish Robin and I will be talking about our exoplanet, K2-34B. But before we get into the details about K2-34B, I would like to first define the term exoplanet. An exoplanet is a planet found outside our solar system that orbits a star. Now that you all know what an exoplanet specifically is, let us dig into the specifics of our very own planet, K2-34B. Let me start off by giving you all some interesting facts regarding our exoplanet. K2-34B was discovered in 2016 by the Kepler and K2 Science Center. Additionally, it is a gas giant that is nearly identical to Jupiter's composition and properties. K2-34b is the only known planet in the K2-34 solar system. Lastly, the average temperature found on K2-34b is 1742 Kelvin, which is nearly 10 times hotter than our own planet. This scorching hot temperature can melt metals and other objects in a matter of split seconds, making it impossible for any living creature to inhabit this planet.
Using the equation for freefall acceleration, we find that the gravitational acceleration on the surface of K2-34b is about 25.5 meters per second squared, which is about 2.6 times faster than that of Earth's. To find the velocity of a satellite orbiting 400,000 meters off the surface, we use the velocity equation for objects in low orbit, which will give us about 4.89 times 10 to the power 4 meters per second for the velocity of the satellite. The ISS orbits at about 7,660 meters per second, so a satellite orbits K2-34b about 6.39 times faster than it orbits Earth. We can find the revolutions per Earth day of this satellite using dimensional analysis. Using this, we find that 1 day equals to 86,400 seconds, so a satellite would travel 86,400 times 4.89 times 10 to the power 4, which gives us 4.23 times 10 to the power 9 meters in 1 day. Dividing this number by the circumference of the satellite's orbit, 2.477 times 10 to the power 7, we get 7.10 revolutions per day. To compare, the ISS orbits the Earth at about 16 times per day. To find the distance between K2-34b and K2-34, we can derive the R equation given our period equation for circular orbit. Using this, we find that K2-34b is about 6.61 times 10 to the power 9 meters away from K2-34. To compare, the Earth is about 1.5 times 10 to the power of 11 meters away from the Sun, which is about 22.7 times further away. Lastly, to find out how fast K2-34b revolves around K2-34, we use our velocity equation for circular orbit, which gives us about 1.59 times 10 to the power 5 meters per second. For reference, the Earth travels around the Sun at about 30,000 meters per second, so K2-34b revolves around its star about 5.3 times as fast as Earth.